In this video, we're going to go through the difference of two squares method for factoring a polynomial. So in the top right of the screen, you can see that I've outlined the three methods of factoring polynomials. And when you're asked to factor, you should always try them in the order that's on the screen from left to right. Because sometimes the first one is the best one and it will get the job done. And other times you need to do the first one so that you can do the second or the third one. So the first method says greatest common factor method. You'll know to use this term when everything involved in the polynomial has a greatest common factor. So for this example here, there's no number or letter that I can factor out of both of these terms here, right? So there is no greatest common factor here. I can't use greatest common factor method on this one. So then we jump to the next method, the difference of two squares method. You know to use this method when it's a difference of two squares. Difference means subtraction. Two squares means that there's two terms and they're both perfect squares. So 9x squared is a perfect square. That means I can multiply something by itself to get 9x squared. And 4 is a perfect square. I can multiply something by itself to get 4. So to factor using difference of two squares, you're going to write two sets of parentheses and put a plus sign in one of them and a minus sign in the middle of the other one. And then you're going to ask yourself what number times itself, or what term times itself is 9x squared? Well, the answer is 3x. So you're going to put that in the front of both of the parentheses. And then the square root of 4, what times what is 4? The answer to that would be 2. This right here is factored out to be 3x plus 2, 3x minus 2. And that's it. That's all we can do to factor this one. After you're done factoring, you should go back and see if maybe you can GCF it after all. And there's nothing here that can be factored, right? 3 and 2, there's no GCF. Same with the 3 and the negative 2. And I can check to see if I'm right by doing box method on this. 3x plus 2 and 3x minus 2. 3x times 3x is 9x squared. 3 times 2 is 6x. 3x times 2 is 6x. 3x times negative 2 is negative 6x. And negative 2 times 2 is negative 4. These two terms will cancel because they're like terms and they're opposites. And you end up with 9x squared minus 4. All right, so let's try the second example here. If we want to factor this, let's start with greatest common factor. And there is a greatest common factor between these two. They both have 3 as a greatest common factor. So if I factor out a 3, I'll be left with 4x squared minus 25. And the reason why we started with the GCF is, like I said before, sometimes what's left over can now be factored using another method. This right here in the parentheses is a difference of two squares. So I'm just going to bring that 3 down, but then I'm going to factor just that part with my difference of two squares, which is make two sets of parentheses, one with a plus sign, one with a minus sign. What times what is 4x squared? That'd be 2x times 2x. And what times what is 25? That would be 5. 5 and 5. This right here is the factored version of that. And this is, sometimes they'll say factor completely. That'll be a hint that means you need to factor more than once. We couldn't have done difference of two squares right from the start because neither of these things are perfect squares, right? So we had to do the GCF to find that secretly there was a difference of two squares binomial in the problem. Let's do one more example here. 1 minus x to the 4th. If a variable has an even number exponent like this, then it's a perfect square. And that rule applies if there's a coefficient in front, like if there was a 9 here, as long as the number out front is also a perfect square. So this is a difference of two squares. The square root of 1 is 1. And the square root of x to the 4th is x squared. So this right here is a binomial factor. This is supposed to be a minus. I'm going to write it again because I'm not happy with that scribble there. I just said I didn't like a scribble, and then I'm going to scribble all over the paper. Can either of these be factored again? This one cannot, right? It's not, there's no GCF, and it's not a difference of two squares. This one can be factored again because it is a difference of two squares, right? It's two things that are square rootable, and there's a minus in between. So I'm going to sneak a plus and a minus. The square root of 1 is 1, and the square root of x squared is x. So this is the completely factored version of 1 minus x to the fourth. And again, the directions would probably say factor, but to give you a hint, they would probably even say factor completely. All right, real quick before we go, I'll review the last method of factoring, the one we learned earlier this week, and that's the trinomial method. So if you have a problem like this, and they ask you to factor it, well, there's no GCF that can be factored out. This is not a difference of two squares, so maybe it's trinomial method. And that means you just take a box, a 2x2 box, you start with this term out front, and say, well, there's only one way to multiply to get 2x squared, and that's 2x times x. And then you make a list of all the ways you can multiply to get 5. There are only two ways, 1 and 5 or 5 and 1, right? And then you kind of just guess and check and put the numbers that you just wrote here in these two spots and hope that it works out, right? I know they need to multiply to be 5. I need them to add up to 11, so I'm going to put the 5 here so that when it goes with the 2x, it'll be 10x. And that would put the 1 here, right? 2x times, or x times 1 is x. And then combining like terms, 2x squared plus 11x plus 5. That checks out. So this is the factored version. 2x plus 1 and x plus 5 is the factored version of that. All right, that's all on factoring. Thanks for watching.